Oops. Hello, I'm actually here. It just looks like I haven't connected my webcam. Let's see. Sorry, not not that this is essential by any stretch, but let's see, can we get this sorted out? No, not coming on just yet. And there we go, I think. Yep, nice one. Hello everyone again, and welcome back. Today is a relatively exciting session in my view. I see it hopefully as kind of coming towards the end of at least the provisional work on the research side of things. Well, still continuing on in the vein of research, but the big change today hopefully is that I'll hopefully finish off with the uh, kind of more core research part, like so implementing the base language almost, where all the say, you know, 90%, 99% of the features are kind of just borrowed, existing ideas borrowed from other languages. Um, but once that's done, I'll be taking a look. Oh, it looks like the stream is a little choppy. Getting a bit of maybe if I close a tab. Let's see. Yeah, I think that's sorted out. Anyway, apologies. So looking at maybe finishing off the research or the more research heavy or again not researchy but the kind of core language part that borrows ideas from other languages and starting working on some novel ideas for the new language that I'll be working on, which is Laurel. It's kind of an alternative to, or intended to be an alternative to Bash, which tries to keep the ergonomics of Bash, but also remove, say, some of the what could be considered the more legacy features that are kept for backwards compatibility reasons. Um, uh, so I suppose, yeah, I'll probably just get stuck in. I added one new task since last time, which is to look at using block or defining blocks, so blocks of new scope, because I was thinking that is a fairly standard feature and should be fairly straightforward. I often say this, but should be fairly straightforward to implement. Another thing that I thought just there as well is um, for assignment having let mutable. No, sorry, I won't do that today actually, because that's um, having constant variables is its own kind of thing. So I won't focus on that today. This should be a matter of minutes to implement. This is kind of a chunkier piece, which is a refactoring of the existing kind of functionality to allow um, to rework the mechanism by which a variable's source object or a field source object is carried around with the variable itself. The mechanism that's done by as well at the moment is the variable is kind of side by side with almost at so the mutex that the variable in is in or the value is in is a sib is basically in the same tuple as the mutex of its source object, whereas I want the inner value of within the arc mutex to actually be this basically to get this kind of a setup instead of what is currently there, which I think is more like this, because this allows for better atomicity, and there's one place in particular where this new structure will allow us to do a variable reassignment in a much safer way, in my opinion. So so those are the two things I'm hoping to get done today, and then once I've that done, depending on how long that takes, I'll be taking the rest of the session to start looking at some of those novel new concepts. The first of which is, I suppose, the first abstraction or idea, I suppose, that that the Laurel programming language will introduce, is that strings will now become callable. And what that means is when you call a string, that string will be assumed to be the name of a program. So in kind of a simple case, if we said something like ls, and now this is an initial limit, the fact that strings at the moment are kind of enclosed in single quotes. So ignoring that for the moment, but it'll mean that instead of, say, languages like, Go, Python, your typical programming languages, where we have to do something like, import package, create a new command called ls, grab output, and so on. This will more or less do the same thing, where if you actually call a string, then that string is expected to reference a program, and furthermore, the values that go in here, these should all be strings as well. The values that go in here will be passed as program arguments. So already this will be the first kind of idea that Laurel will introduce to make calling programs more ergonomic than your standard programming language, to try and keep that ergonomic nature of Bash. So with that said, yeah, that's the kind of intention, but it'll depend on how quickly I can get the rest of this stuff going. So first one anyway is block. Again, I often say this, but I don't see this posing too much of a challenge, but we'll see. It should hopefully be a matter of, we even have a whatchamacallit, a production representing a block in the parser already. So actually, I would need to introduce a new AST item. So it'll just be something like that. And the semantics here would be that it basically just introduces a new scope, is the reasoning for this. So you can have, okay, and here's a potential issue that, and it's something I was potentially wondering would it happen, but yeah, there's a conflict in the grammar if we introduce this rule. So that was the one hiccup that could have thrown an issue in here. So let's see, what's the conflict here? Again, LALRPOP's conflicts aren't the easiest to reason about, really. Maybe can I comment out a chunk of these? Now the only thing is I could end up commenting out the chunk that the issue actually presents itself in. So what comment style does LALRPOP support? Something like that, maybe single line comments. Okay, so the conflict is getting introduced with one of the statement productions, as we might expect. It looked like it was being introduced by the if, but I would suspect that it'll be as prevalent in the other kind of block specifiers like while and for. So with that being the case, let's just try and narrow it down and see if there's some obvious resolution. Okay, so it's even being showing an issue there. Okay, so okay, and with those as well. And let's see, does it cause an issue with these? And just to double check, block is basically surrounded by braces. Okay, so let's start with maybe which would be one of the simplest of these. Let's look at return expression. And that might not actually have a conflict, does it? Okay, no, that doesn't have a conflict. So at least not all of them are resulting in this conflict. So let's take a look at maybe one of the more obvious ones, and it'll depend on how far back I can scroll as well, whether I can see all of this stuff. So here's what could be an example. Local ambiguity detected. The problem arises after having observed the following symbols in the input statement, followed by an opening brace. At that point, if the next token is a closing brace, then the parser can proceed in two different ways. Could produce a prop list, which would then result in an expression prime. Okay, so yes, absolutely, because we're using the same syntax. No, that makes total sense for uh, for objects for dictionaries. How does JavaScript work around that? Maybe some amount of look ahead. But yeah, I suppose probably the issue is that we can have kind of an expression on its own. And say if I disable that, what was the issue when, say, I uncommented one of those? Oh, one issue here actually. Oh no, that wouldn't end with a semicolon. Okay, so that's allowed. How about this? So I can see the dictionary issue being a problem. That's all right. So then the last of these was causing an issue a moment ago. Let's see where we're going wrong. So this is a prop list issue as well. Looking at a token let, we can reduce to a prop list, but we can also shift. Not actually sure where the issue is arising here, because in this case, if this couldn't be replaced, so if there was an empty block here, for example, that couldn't be replaced by this because it's followed by the equals. And so the parser should ideally know that that's, what that is. And then on the right hand side, similarly. And is there a way we can resolve this with kind of having, similarly to below where we have kind of a higher binding? Yeah, this is just going to be a nice little add-on if it was straightforward, but it looks like it's actually, again, because of the conflict stuff and because of this stuff with, you know, the fact that it's the same as a, but again, I get expression matching it, but the fact that a block won't be followed by a semicolon and an expression should, I feel, should distinguish them, but I know for whatever reason that's an issue. To be honest, it's not something that I need to have right now, so it was going to be a nice to have for the first, you know, few minutes of the stream if it could be done. Doesn't seem as straightforward as what I was thinking, so I'm actually going to leave that. The more important one, did I keep, I probably kept the evaluation for blocking here, did I? Yeah, or not evaluation, but the parsing rules. So the one that I'm more keen on actually sorting in this stream, and before I move further on with the rest of with the start of the Laurel programming language, is the scope, or not scope stack issue, but the definition of. Am I actually still using either? The definition of is it ValRefWithSource? And at the moment, ValRefWithSource is carrying a valref and the source is next to it, but I do want it to ideally be in there. So we would probably call that ValRefWithSource prime for the moment. And this actually won't just be an unadorned arcref, it's going to be an option. And in fact, I will make that an enum as well. Or not, sorry, not an enum, but a struct. Again, probably opening up like making a bit of trouble here for myself, but I think it's the right thing to do. Sorry, that wouldn't be ValRefWithSource. That would be, we could have ValueWithSource. And let's see. Then ValRefWithSource would be an arc mutex around a valref, or sorry, ValWithSource. So let's try that. In fact, yeah, let's just rip the band-aid off right now and call that ValWithSource and replace it and see what work actually needs to be done here. So new valref. Something going wrong with that anyway. That's interesting actually, that when there's an issue with, say, the types of defining a function, then the function, as might be expected, doesn't get defined. What line is that? 1197. Most of these are issues in main actually. Because if val isn't compiling. Because there's actually a syntax issue. Okay, yeah, as opposed to an actual typing issue, for example. So let's see, what are kind of the issues I'm running into here? 1200. No field name source. So first of all, this will need to be, let's see. The new thing will need to be a value with its source. Uh, 1035. By many direct instantiations of ValRefWithSource. Have good few. Is there any pattern amongst them? So there aren't too many calls to the constructor. So basically 3 calls to the constructor and then one with a destructure. So in that case, let's see. So it would be new valref. At the moment, that's what it's called. Probably makes sense to refactor that in a sec. Yeah, what I'll do is the usual gist of get it working now, tidying it up later. Swear I will tidy it up at some point and actually follow through with that. But let's see, that would be, instead of valref with source, that'll be a val with source. And then maybe do the same thing with those. Try that. 53 errors, at least we're going down in number. That's the correct direction for the number of errors. Expected value, got that. So let's see. So at the moment, maybe 1033. maybe I'll take new ValRef with this. I have to make sure all my test files work after this, but that one should be all right. 52 errors now at least. Yeah, there's a big number of a good amount of destructuring going on that I'm going to have to work with. And yeah, I'm going to have to, because I'm generally doing the lock on the inner data and I'm reworking that, I'm going to have to, yeah, just rework a lot of the existing code. So let's see. Source. ValRefWithSource is probably a bad name now that it's a reference to both the value and the source. It more likely to be something like val with source ref, where both are being referenced, so to speak. Yeah, I suppose we just have to kind of go ahead and yeah, work on this. So this instead will be something like v or value maybe, and source isn't in scope yet. And then when I match the I won't need to match the actual unlock here. It'll be something like that val ref with source is equal to the unlock there. And yeah, I'll probably have to play around with that a little, but something like that. 1034 new valref this expected value found as something or other. Let's see what's going on there. ValRef with source has inaccessible fields. Oh, I'm mixing up ValRef with source with val with source. So that should be that. Okay, so we've lost some errors there. Let's see, 979. Okay, so that's out of that section. So if we go back to 1010 and the new valref. So this now is already in the expected format, I think. Oh, can I do that? Wait, what am I doing? Sorry. ValWithSource. Recursive type. I might need to box it. Okay, no, that's all right, but yeah, the reference is mutable. Can I get rid of that mutability? Okay, I just could. 979. Oh, but am I going to be answering for that later with the borrow checker? I wonder. Oops. Oh. Oh, going all over the place today. Okay, so we have vals here. Applied binary is probably taking, yeah, values like that. I could probably do the V at the end there instead. That'll probably be a recurring issue, yeah, 958. Yeah, it's basically, oh, the names are so terrible. I know I've said that before, and I'm not making excuses about this, but they're not good. They're functional, but yeah, that is definitely something to be cleaned up in time. Let's try that now. Yeah, it's reducing the number of errors. 918 though is not fixing it because V can't be dereferenced. Let's see. So yeah, that's an unknown field. And maybe I have to do it like that. 888, yeah. Turning into a little bit of a mess here. And by little, I mean, ooh. So 859. Again, a lot of this will require probably a bit of yeah, some abstraction to deal with the mutex guards, with taking stuff out of the mutex guards, so that the yeah, just the kind of abstraction around the mutex guards can be kind of handled uniformly, rather than it's fairly it's done fairly manually at the moment. I don't think it needs to be that manual for the most part. But again, it's one of these things that would probably take a few. I don't want it to derail the kind of regular Saturday slot where I focus just on the language itself. It'll probably be its own refactoring session. But yeah, that'll need to be done at some point, definitely. Expected a value here, but got a value with source. So what do we do instead? So what's this doing? So this is actually getting a property from an object, and it's kind of one of the reasons why we have val with source. So thing here is to turn it into a new kind of, so starting off with the value, so that's taking the value out of v, so let's see, source, first of all, we'll do that. So it evaluates so when we evaluate a property, expression, I suppose maybe call that object instead. So evaluates expression, it has to be an object. And it's going to override the value down here anyway. Maybe something like that. Yeah, I think those V's aren't necessary anymore. Expected a value here, but found an arc mutex val with source. So I would probably need to extract the value out of that value with source as well. Very hairy, but let's try this. Oh wait, no. So I can just do let field val equal that. Oh. And yeah, so that seems to work for that. And then for this, let's see, new valref turns a, so that basically creates a new creates a new value without a source. I don't have any abstraction for creating one with the source, but since that happens so rarely, then I'll probably just do it like that. Yeah, and that seems to have resolved the issue. 840, get index range, expected reference found a struct vec, consider borrowing here. Now I'm not sure why that's happening. Yes, so it's the back to the usual thing here, where it's like that. I should nearly create a macro for it at this point. But it's all right to do by hand for a little while longer. 797. Oh yeah, there was a sneaky one there. And 756. So this is similar to below. And what's so that's indexing. Okay, yeah, there's two ways of basically doing the same thing at the moment. With object properties, you can, same as JavaScript, you can access it using indexing, or you can access it using kind of a property field. So I basically need to do the same same resolution here. So oh, hey, CKip, welcome to the channel. So let's see. Again, let field val equals that, and in fact, I'll rename that to prop val. Doesn't make it too much better. Again, very generic name, but you know, there's just so many v's and values flying around the place at this point that just need to add some bit of sanity back into the equation. So arc new, new text new, and add an extra closing bracket there. Was there something else I did with that before? Can't remember. Let's see. 735. No, it's moved on to the next section, so that's all right. Then that might, no, that will need that. Yeah, I had a feeling this would be kind of a bit of a laborious refactoring, but I do think it's the right thing to do and probably the right time to do it. This would be needed at some point sooner or later, I believe. So I'm good to get it out of the way now. There we go. And yeah, I probably won't recompile for a second. I'll just deal with a chunk of these in the meantime. That's a good number of them done. Oh, there's another one. And again, all of this is basically taking, ooh, that'll be an interesting one. I wonder, I was able to remove the mutability of another one down below. I wonder if that'll still be the case. But anyway, yeah, this is basically resulting from me taking the, or reordering the kind of location of the value reference relative to its source. So I'm basically just having to put wherever I had been extracting that value before, just have to reposition it. Whoops, where did I go there? Let's try recompiling that. Okay, down to 6 errors. That's positive. And the same thing there. And the main feature to check after all this is done, I think, is just field access and the actual behavior of this in a function or anywhere really. But so that's in main. Okay, so we're out of eval at least. And so we seem to have one lifetime issue, which if that's all there is, or one borrow checker issue, and if that's all there is, that would be very nice. Can't move out of dereference of that. Consider borrowing there. And that means that that is like that. And I think if I clone that, I can get around that. If I clone this, I can get around that. Okay, so we're back to, again, back to very verbose value printing, but at least that is compiling again. So yeah, that could be another little bit of work, but that's coming in under the hour at least. So what I can do is hopefully, again, I'll do a bit of testing. That all works all right. Then, so what was I? So yeah, do a little testing, clean up what's there, and maybe refactor print a little so that it doesn't print the source every time. And then that should be about it for the first half of this stream, and then the second half I can look at new language features on a new branch. So that, yeah, very exciting. Hopefully get that done. So this was testing what? So going into an if, I think, oh yeah, so this was testing scopes. So if scope. So let's see, I need to, oh yeah, test this implementation. So if I rename that to just test.txt, yeah, so that should be a sufficient test if I could read the output. So let's take a look at that refactoring of print that I was saying, where it could ignore the sources of the values. So let's see, if I go into a val, and so this will take a ValRefWithSource, and what I'll do is I'll define a render function, which will just be basically called to Does Rust have sprintf? Like print to string? Oh no, it's just called format. Yeah. Just me being silly. So it'll take a valref with source, and the intention is to return a string. It should, I wonder, would it be fallible? We'll see. So so let's see. It'll match on v and figure out what we need to print. So basically, if the value contains anything that can have a oh, thanks for following. Who now WT1F? So, oh no, WT1W. Thanks. So so basically any values that can then contain, well no, I won't be printing that. So it'll basically just be lists and objects. Any yeah, or functions. So yeah, any value that can any composite value essentially will I'll recurse into and remove the sources from that, and then what will I do then? Yeah, all other values then I just format as is. So so again, use the debug. No, I won't use the. Oh yeah, I'll use the debug by default. And format the value. So that's v in this case. I wonder, will this yeah, I'll just thinking about how the arrays and objects are going to be formatted, but that's that should be all right. So let's see. So with a list of x's, whoops. Oh. So with a list of x's, yeah, gonna iterate over those, and that'll be mutable, of course. And no, it's probably not the best idea to assume that this will. Now, formatting of this could get a bit messy because I'm inserting new lines here, but you know, we don't have control over when new lines are going to be inserted here. So that could be a little tricky, but that should be all right. And actually, if it's a valref with source, then I want to I assume lock and unwrap that, and take the v out, and and this will be a new v. So maybe I'll call this value just to make it some bit distinct. So for x and x's, gonna render x, concatenate it with s, probably just use format again, this isn't going to be the most performant, but hopefully, this is more for functionality, and then later, hopefully, enabling Clippy and things like that will allow me to address a lot of the performance issues. Now I know it's not a silver bullet either, but it is very helpful at the same time. And once Clippy cleans it up, it'll hopefully make the code a good chunk simpler, and then allow make any additional enhancements more obvious. So in this case, so what does a prop look like? Is a hash map. So name value. Line 88. So is that close to what I want? I think it is. Yeah, and it doesn't look like there'd be anything, any reason to make it return an error. Yeah, so 8 expected a string, found that kind of a string. I don't think I can, yeah, so maybe I'll just do toString. And yeah, there's probably going to be concatenation stuff here. Maybe what I could do is that. Or maybe string new. $79. Format expected a string. So can I do toOwned or something? Or can I do that? Oops. Uh, 68, consider borrowing there. Yep. Found a reference. So I need to clone the reference in that case when doing the recursion. And yeah, that render is never used, but that's going to change here. And we'll see just how mangled the move occurs, because value is arithmetic file with source, which doesn't implement copy and can't move out of index. Can I do a clone there? Okay, so that's simplified things at least. Not really sure where the where the new lines are coming from in that case. Oh, it's coming from here. So I think yeah. So now that's been a chunk of work. So let's take a look and confirm whether that's actually the expected output of this test. So we go create a new set X's, set A and B, check does the set have A, and it does. Then we do the same with the index access for functions, and we get the same result. Then we go, this was a test of something else, wasn't it? So this was setting a property to 1, then incrementing it, and incrementing it using a different ordering, and then outputting the result, and the result is 3. And then finally attempting to print this itself, which only exists within a property, and that fails. So again, not the most rigorous test. Again, testing like linting and like actually coding in a clean way, that will be done on the mainline branch, but so far it looks like that is working basically as expected. And so that's this to-do item done as well. So that's that done. So let's see where we at here now. Yeah, so that's compiling, and I think that's about good enough to go. But yeah, just give a quick run through here while I add all those changes. Surprisingly, yeah, basically just had to, it was kind of a, whoops, there's a commented out function there that I don't want to add. Get rid of that. So new valref, maybe arc new. Yeah, maybe I will create a function for that. So that'll be new valref with source. New valref as expected. Given the type name. And do basically the same thing there. Prop val source in this case. Does that compile? No, it doesn't. Not one bit, but then the parameters are all wrong. So I'll take a value with source there. And in fact, that's a valref. That's a valref with source as well. So so I should be able to use the other type for that too. So I'll get rid of that. And I doubt anyone could imagine what's coming next, but new valref that way will be renamed to new valref without source. Although that doesn't maybe not. Maybe just a little too verbose. So new valref with no source. Yeah, maybe. But anyway, this hopefully should be possible to change that, and similarly down here. Nice. So let's try that. Yeah. Looking cleaner already. Yeah, and that changed to render. That test changed, and yeah, I added a new file. Whew. So let's see. So that's all done. Finally, git commit refactor ValRefWithSource to nest source. Cool. So with that done, that then means, oh, and I am unfortunately eating into the time for the rest of the stream, but this was one thing that kind of half inspired this this refactoring, was the fact that instead of overwriting the value being referred to in the scope, it was actually overwriting the binding rather than overwriting the kind of value within that binding, because of the existing structure essentially. I go into this in more detail in the previous stream. So what I wanted to do basically is get the let's see where. So get a key value. I think let's see, unlocked scope. So a scope is a valref with a source and a declared type. So that'll be a valref with source, and then should be able to replace valref with source with the new value. Can assign which is behind that kind of a reference. Unlocked scope. The value you get out of an arc mutex, I believe, is a mutable reference. So I'm not fully sure why I can't. So it's behind an ampersand reference rather than a mutable reference. I'm not sure why exactly that is. Could it be because it's get key value rather than and I'm not actually using the key there, so I'm not quite sure why I'm using get key value. So Rust hash map get, and so that's going to return a reference either way, but then I should be able to extract out of that, out of the valref that I get out of the hash map, shouldn't I? So yeah, so that's a valref with source, so I should be able to dereference that at least. If I lock it and unwrap it. So let's try that. And would I have to lock and unwrap the right hand side as well? Is what I'm doing, does it actually make sense? So basically what we have here is not a box, but I suppose just a cell, and I have some value in there, and then I have a value on the right hand side which I'm wanting to put into it. Can I do something with mutexes? So I know, for example, options, you have the ability to replace the value inside the option. Can I do something like that with mutexes? Get mute. What's the difference between using that and lock? That acquires the mutex. I suppose my gut would say that it's probably the mutex guard is probably just safer in some way, but I'm not. It's not making itself obvious to me right now. But let's see. So I have valref with source. I've locked and unwrapped it, so then I have a val with source. Maybe even just Googling Rust assign to arc mutex. So it has a direct mute implementation. So if I do a dereference on it, then I get that mutable reference. And so I can do that when I do a lock unwrap. So maybe if I don't need the mutable version, but then if I do that get mute, so that's trying to get the original in there. Maybe if I clone it though. But that's not actually what I want, because because that's then cloning the inner value rather than the reference. It would be like whenever I do an assignment, it would do a copy, I would say. So let me just see and test that out. So just comment all that out. I'll do let x is equal to a1, let y is equal to x, ya should be incremented, and then I print x, and that should give me a equals 2. Like if it was working, a is undefined. I'll try printing x up there. Oh, because yeah, variables have to be or field names have to be explicit. Yeah, so a is being printed as 1 because it's being copied here. So y now has a new object rather than the reference to what x is. And what I want to do is put the reference. So maybe the binding actually is the changing the binding is the correct approach. Let me just oops. I'll undo all of that. And what did that old comment say? This should ideally overwrite the value stored in this variable instead of introducing a new variable with a new binding. So first of all, what I'll do is I'll remove that stuff, because regardless of where I go from here, getting the key back isn't necessary. Hang on, even with the old implementation, that's not working. So what's going wrong there? So if I print y here, did I see n somewhere? Oh yeah, it's just that the formatting is a bit messed up because of the kind of the mix of manual rendering and format based rendering. But anyway, oh, a just isn't getting incremented at all. Now, why is that? That could be, well, that is a bug. Let's see what happens with that. So in that case, both X and Y are doing what they're meant to. And this is going to be ValRef with scope. With source, sorry. Oh, so that's actually that's working fine. So it updates updates X as well. So why is that actually? So if I take a look at, so V in this case is ValRef with source, so it's an arc mutex, and then the value underneath is the object. Locks and unwraps the arc mutex, and then clones the actual object underneath. So what it's probably doing is a shallow copy. So while the value under A is probably handled correctly, if I were to add a new value to it, so for example, Y, actually I'm not sure if I've done this where you can add a new field to an object. Haven't tested it anyway, I don't think. Okay, so it's not actually doing a shallow copy either. I'm a bit confused by that. Now, having said that, I'm not going to let it derail the current session. It has opened a number of, or kind of highlighted a number of issues that I need to follow up on. Well, this isn't an issue, but it's an interesting thing that I hadn't thought about. It seems to work kind of fine, but I hadn't thought about it is adding fields to objects in this way. It actually works fine, but I'm actually not sure why. So I'll investigate that. I'll add it to the to-do list. So if I go let x equals that, xa equals 1, print x. Yeah, a is equal to 1. So kind of to do why does that work? To do demo methods with closure, I've done that. So that'll be an investigation section. Again, hopefully most of these will be addressed and covered with proper tests in time. But let's see. I'll just copy this chunk down here. And the following seems to work. Investigate why the clone on the right hand side allows the reference to be kept but or instead of doing a clone or shallow clone of the original data, for example, and we'll paste this right hand side down here. In the following, modifying y actually modifies x, but I'm not sure why. Cool. So yeah, and so I'm just gonna get rid of that for the moment. At least the context is preserved. I'll keep this change where I only get the value from the unlocked scope and not the actual what am I trying to say here? Not the actual key, but yeah, that's a bit disappointing. Again, one of these things that it's crazy. Some of these things that I think will be fairly straightforward and simple just don't seem to happen. So, but at least it's given me a lot of food for thought and highlighted just some things that I need to confirm and double check in the, as I add more tests in the future. So here I'm saying remove redundant key retrieval. And push all that. All right, so next thing, yeah, time to branch out. So check out this. So clean branch, and now, yeah, probably wouldn't be the most. So as we've seen there, I've identified what are probably a few bugs in the existing implementation, or at least areas where I'm actually not sure what why things are working the way they're working. Is it a bit kind of I suppose reckless to then start looking at the syntax for this new language? Well, I suppose that's the thing, is that I'll actually just be focusing on syntax, and that's kind of the reason for this base language, is to focus on syntax and what works grammatically rather than the actual evaluation, the strict evaluation rules of the new language. So with that in mind, I'm actually happy to keep going with this and start playing around with the syntax of the new language, at least, so that it's the actual semantics can be adjusted later, and it's my main kind of goal with this part of the research is to just play around with syntax and see what's actually possible. So first thing to do, and in fact I don't think I need to add any new grammar rules for this. It's actually purely an evaluation level update, and this is to update calls and how they work. And at the moment, you can call a built-in function, you can call a regular function, and now you're going to be able to call a string. And so what's going to happen here? So this is an area that's going to kind of add a lot to what value handles. And there's going to be, again, so processes, programs, things of that nature are going to be first-class citizens, aka values, in this language. So I'm going to be popping those support for those kind of things down here. So at the moment, I'm just going to define, quite simply, what would I say? At the moment, I'm just going to define, the outcome. So, I'm not going to be defining processes in here right now. Calls are always going to be synchronous. So, for this level of the feature, so it's basically going to return. Well, it returns when the sub process returns or exits, and it's just going to basically contain the output. It's going to be a capture. Going to have capture semantics. So I'll just put process results there, and I'll have to remind myself the Rust process stuff. It is nice, I think, if I recall correctly. Standard process command. So and so in here we're going to have command new, is it? Yeah, and so the value that's going to be in here is the actual string. The oh, hello, man of bad feels. Welcome to the channel. So so the program that is going to be run, so I'll call it prog, is going to be that. So we'll also be getting, let's see, more than likely, so we have this scope. This isn't actually defining the evaluation. Oh no, so this is actually defined in a couple of steps. So so we have either left, right, or oops, I've kind of not painted myself into a corner here, but I'm going to probably have to add a new disjoint value here. So let's see. So if it's a func, can't actually remember the exact reason why that's split up the way it is. I think it's to do with the time at which values get unlocked and relocked. Yeah, that was it, wasn't it? So values get locked here, reference to here, and then unlocked down here, and then the body is kind of free to proceed. It allows for recursive calls without deadlocking on mutexes. So where's my best? I actually have to do the same thing down here. So so anyway, the values that I get here are going to be not new bindings in this case. So it's what I can basically do is hop through not arg names, but vals. And so I'll go for val in vals, and I'll be I think, do I need to evaluate those? I think they're already evaluated there. Yeah, so I evaluated the args already. Is it is that oh, I think it's probably a list literal, is it? I'm not sure how else that would work. Oh no, eval expression, so it's passed as a list. In fact, that's the only call to it. So it's returned as a vector as well. So they're already evaluated. So what I can do is I can go through those, make sure that they're all strings. And so what would we call those in here? They would be, yeah, I'll call them args again. That args is maybe vals iter and map. Oops, where is my pipe character? There we go. And match v with value string. Now I'll probably have to do locking on that, but anyway. So string s, otherwise it's an error, although an error inside the map. Oh, maybe I'll do a for loop actually. Yeah. So again, probably not the best way of doing this, but probably the fastest way. So match val with value string, and that would mean args push s. That'll have to be mutable. There we go. And if that's not the right type of value, then say what are they called? Program arguments must be strings. So that's that. So now I've got all my new I've got my parameters to the new program. So this will have to be kind of a new, either I'll just call it up. So we've got left, right, up. And that's in a tuple. This one doesn't need to be. So the value here is, and I'll rename either in a second. Like I'll be renaming left, right, and up to something more appropriate. But for the moment, we'll go args is that, and then it'll just be output. Will be what I put down there, in the match down here. And oops, so value in this case will be CMD. And I'm going to just grab output for now. What does output return in this case? Gives a result object. So it'll have to be a match on that. At the moment, so in this language, it's going to swap the default of bash. So bash generally is continue on error, whereas this language will be failure on error, but it'll be very easy to catch that error is the intention anyway. So in general, a process that returns non-zero will cause the script to abort, but the it should be very easy to specify that a particular line, you can ignore the result or what have you. So put that there. Retval, no, that's output. Otherwise, if there's an error, then return format process failed. Bad Fields got a theoretical question. How does a parse tree get converted tree address code? So I'm guessing this is related to actually how would this get, for example, if I wasn't writing an interpreter and actually writing a compiler, how would the instructions for that look like? Is it, or am I misunderstanding that? Sorry. So process failed, and it will just print E then. And then the output will get converted to what will that be then? So these are returning some and none up here. Not actually sure what that's about. Match on retval. Oh wait, no, sorry, they're not returning those values. They're returning v and a new valref. So I need to return a new valref as well, except in my case, the new value will be, let's see, an exit status, standard out and standard error. And at the moment, it'll be an unsafe operation, but I'll just to illustrate the concept, I will be converting standard out and standard error to strings. So this will be an object, which would be props, and I think that's a hash map, isn't it? So let props is equal to, let's see, hash map new props insert I could probably do a from thing where I have a vector of key value pairs, but just in the interest of time, because I do actually have to leave quite promptly at the end of the stream, so that's about 14 minutes away now. I'm going to try and get this done kind of as quickly as possible. So this will be a new valref as well. Value, and the first value will be a, let's see, exit status. In fact, it won't be an int. I'll just call it OK, and it'll be bool, which will be B, and it'll be the success of the exit. So status. So man of bad fields. So I'm thinking after lexical syntax and semantic analysis, you get a valid parse tree. Yeah, in that case, how do you go from the tree to intermediate code? So tree address code like R1 is equal to A plus B, R2 is equal to R1 multiplied by C. Yeah, so that would be kind of similar to, yeah, I suppose I haven't done so much with intermediate code myself or intermediate representation, but my understanding is it's probably similar to when you're outputting, say, assembly code, and the process is, from my understanding, it's, I suppose you boil it down to these kind of discrete blocks almost. So again, I actually don't have my tablet here right now. It'd be much easier to go through that there, and maybe I'll go through it on the next stream. But basically, if you had an expression, and I'll type it up here, so such as let's see, 1 plus 2 plus 3 with your conflict resolution, or your the way your AST is parsed up, you'll have some kind of binding. So one of these is going to happen first, basically, and it'll either do it left binding or right binding. And what will essentially happen is, this is kind of a generalization, but my understanding is what will usually happen is, if we take these three instructions, the compiler will need to output assembly code so that a CPU can run this. And a CPU has a limited number of registers, and even if they were infinite, it needs to kind of figure out what registers are going to be holding what data. The simplest way it's probably going to do that in general is, it'll start off and it'll say, even if you had just 2 registers, how you'd do something like this is, you would more or less say register 1 is equal to 2, register 2 is equal to 3, and then you would do register 3 is equal to register 1 plus register 2. Again, that's going to be even abstract in terms of what the CPU, or what the assembly language does, but it'll probably be easier to transform into assembly language at that point. And then at the last point, well, number one, it'll probably usually do it something like that. But even if it did something like this, what you'd usually be ending up with at the end is the result basically going back into the first register in general. And what that means is, basically, if you have this tree of nodes, you evaluate each it's generally going, each node is generally going to have, if we keep things simple, is going to have 2 children, and so it basically starts collapsing from the bottom. So if I have my AST of this expression, it's going to, look something like this. So plus 1, and then there's going to be a plus here, and we're going to have 2 here and 3 here. And essentially what you're doing is you do a kind of a depth first search, recurse down the tree, and is effectively what will be happening. And this calculation, because it's deeper or it's required for this one, this sub evaluation will be done first, and the whole result, the expression will be resolved, and the result will just be in R1, more or less. And then this one, evaluating from bottom up would be, yes, like again, it's been a while since I've looked at this kind of stuff, but it would be because, even instinctively, that's how evaluation would work, because the top level nodes, or the nodes higher up, depend on the results of the lower branches. So you naturally have to evaluate those first. And you just kind of do it sequentially, basically, and the a very naive way. Now again, these things are much more optimized these days, so what I'm explaining is a very naive approach. But essentially what you can do is, whenever you have an operation, you can probably generally boil it down to an operation on 2 values. So for example, this was originally an operation on 3 values, but we boiled it down to an operation on 2 values first, and now we have this value in a register. And what would probably happen at the end, like I said, so this was, originally in register 3, and we just put it in register 1. And then now that so this is register 1 now, and what the what the compiler could then output in assembly language could basically then, now that this is R2 in the new kind of situation, so this is R1 in the new situation, and this is R2, the compiler will then say, okay, R1 is now 1, and R2 is, or sorry, the value in R2 is now the value that was in R1. So it'll do that probably as an intermediate step. And sometimes it'll probably do stuff like this. And what will often happen is, in intermediate code, possibly before optimization, you could do these things called peephole optimization, which is just, when there's stuff very obviously kind of being optimized, such as this, where it's redundant, you can just remove it. But before those kind of optimizations, the compiler will generally spit out kind of what seems to us, because we have a broad view of what's going on, what looks redundant, but is basically just shuffling all the data around and making it very easy for the CPU to execute. So such as, take 2 items, put them together, put them in a location, then maybe push it on the stack or something like that, add 2 other numbers, push that on the stack, and then even put something on a stack and then take it off the stack and immediately use it, because the compiler is just outputting these kind of dumb instructions, basically, for the sake of kind of simplicity. And then you get into the likes of if statements and while loops, which are very interesting. So an if statement and a while loop, what those will essentially output is an if statement. Again, will probably evaluate the Boolean logic same way as being done up here. So break things down, make them very simple. And then if you, the logic at the last point is, you essentially end up with a Boolean, which will be encoded as a 1 or a 0 normally. And essentially what will happen is the compiler will effectively output a goto. And so, if we had, so up. So if I had, if true here, what that's essentially saying is, or if v, and I have my statements here. what that's essentially saying is if this value is true, keep going. And so if those statements got evaluated into a number of steps like A, B, C, D, then at the start of this sequence of statements, we'd basically have a check. So first of all, we'd evaluate V. So it's a big load of R1 is equal to 1 and so on. Eventually, we'll get to a point where R1 will just contain a value 1 or 0. It'll be the Boolean value. And then we'll have a check, and it'll basically be a jump check, which is kind of a CPU go-to, a CPU level go-to. And it'll basically say if R1 is true or is 1, or sorry, if it's 0, then basically go to label X. So assembly language, the ones that I'm familiar with, basically revolve around the concept of labels. And so what would effectively happen is if this evaluates to a negative value, then skip all of these statements effectively. And similarly with a while loop, is it kind of does the opposite, is there'll be an if statement after all the statements and before. A do while would have it just afterwards. But basically we'd have the label X at the start and at the end. So we would actually have this here and label X, and then we'd have label Y maybe down here. And so we would have this thing, and it would basically say if the value is false, then jump to the end of all the instructions and skip them. But if the value is true, just continue, and if the value is still true, then jump back to the top again. So again, don't have too much time to go into it today, otherwise I'd probably go through it in a bit more detail. But that is kind of a very simplistic way that we would turn, say, this interpreter into a compiler that outputs assembly language. Excuse me. Now that does put me in a spot here for implementing the last bit of this. Maybe if oh, thanks, glad to hear it. So so I'll just see, can I get this working rather quick? So we have either left, right, or up now. So I have command coming down there. Let's just see, does this much at least work? I haven't gotten the output, and I haven't converted standard out to a string, but this might be enough to show at least some of the basic concepts. So I 1 minute, maybe 1.5 to see some of this working. So expect a string, found a string, so that needs to be converted to value object expected struct string. Oh, so that should be to string. Variant not found in either. That should be sorted now, I hope. 1062. This has an arc mutex. Do I have to lock and unwrap? And I have to dereference. I probably have to get V out as well. (1063). Use a comma there. Yeah. Okay, some lifetime issues, not too many though. Props equal to hash map. Yeah, that needs to be mutable. 1067. Let's see. Command program arms creates a temporary which is freed. So maybe I can putting a mutable. I can put a mutable variable in there, I think. But I'll need to define that actually on the either. So yeah, let's just do that to cheat for the moment. This won't be going into the repo as is. Oops. I can't make that mutable, no. Rust enum mutable field. Let's see. Can I make the can I make that mutable maybe? 1062, can't move it out of dereference, consider borrowing. Yeah, whatever you say. Going over time a little now, but oh dear, what's happened here? Oh, change that to be mutable CMD. No, that didn't work. Probably put it in the wrong place, but 1104. Okay, that has to be like that. Okay, and that probably doesn't need to be mutable then. 1062. What's happening here? Creates a temporary that's freed while still in use. Because I'm using the strings as is. 1021. Mute doesn't need to be mutable. Okay, we're sucking diesel now. We have a compiling thing. So let's try ls and I call to that. And there is the first, hopefully, quote unquote, running Laurel program. And we have, it just returns okay, okay is true. So then if we call false there, the program false, which just returns 0. Actually, it won't even return oh, it does. Sorry, non-zero value at the moment doesn't equate to an error. So and it doesn't equate to an error in Rust. So that's actually fine. But it's basically, yeah, coming up with the output. Can I take another minute to add standard output? Probably not, unfortunately, not today. Have to run, unfortunately. Delighted to have that first kind of little bit of implementation. Again, only evaluation level change necessary. It was just updating the call semantics so that it can be called on a string. But yeah, that's I'm pretty happy with that. That's the first running Laurel program, so to speak, and eventually we'll be looking at removing the strings from those. And yeah, exciting stuff. Really looking forward to getting more into this. Thanks to everyone who joined in with the chat as well, and to anyone who's subscribed during the stream. Pleasure to have you on board. And yeah, I look forward to seeing everyone hopefully next Saturday for the next session. I'll also be intending to upload more of these videos this week. I have bunch of editing done, so I can upload a few more to YouTube and any other stuff. No, I think that's more or less it. Again, thanks everyone for watching, and I'll see you again. Take care.